users tend to design working, starting out with the top plane. That's how the most designers or users have been taught to work in SolidWorks is start out from the top plane and you build your part. So the top plane happens to be the X and Z axes. In CAD systems like Rhino, VisualCAD, AutoCAD, or several other CAD systems, the top plane is typically your XY plane, and in SolidWorks the top plane happens to be your X and Z plane. So if the parts you're designing are in the X and Z plane and you built the part, as you can see one of the parts right in here, you will notice that as you look down through the part, your Z-axis is not being normal to the face or normal to the side you would like to or you intended to machine from. So the best way to orient your coordinate system from your transforming from the design coordinate system into machine tool coordinate system is by using this feature called machine tool coordinate system under the machine tool setup tab. And under this tab you can orient your coordinate system by rotating the coordinates and not having to rotate the part and recreate the part in your CAD from a different plane. Now by default the machine coordinate system is oriented in the same orientation as the world coordinate system. So the world coordinate system in SolidWorks typically appears over on the lower left corner. You can see your Z axis and then the X and Y axes, and you'll notice that the world coordinate system and the machine coordinate system in VisualCAM appears right where you have the origin in SolidWorks. So that where your default origin is located, that's where you'll notice that the world coordinate system and the machine. Again, the triads are represented very similar to one another. The machine coordinate system visibility triad is slightly larger than the world coordinate system visibility, and the orientation of the world coordinate system is in the same orientation as the world coordinate system of SolidWorks and is by default at the origin location in SolidWorks. Now as we would like to mill this part looking down from the top, which means that our Z axis for machining has to be normal to this particular face. Now currently the way the part is designed, the Z axis is not normal to this top face, instead is normal to this face in here. So as you look at it from a front view, you'll notice that the Z axis is normal to this particular face. So we need to change the orientation in here to be able to orient this part on the machine tool so we can effectively machine it. So we're going to go into machine, and then we're going to go ahead and select from one of these options in here. Now there's several different ways to do it. One of the techniques is using select surface, and you can pick this face, and the Z-axis would be established based on the normal of the surface that you select. You could also use the set orientation to world X, world Y, or world Z. So if I pick world Y, you will now notice that your Z-axis is now oriented along the world Y-axis. So you can see that the automatic transformation takes place, and the Y would be now your Z-axis. Or you can go back and use the additional controls in addition to these to rotate it. So if you like the X-axis to be parallel to the longer side of this part, you could use these controls to rotate it in here. You can specify a spin angle, and also you can specify what coordinate axis you'd like to rotate about. So once you have these established, you select OK, and you will now notice that as you toggle the display of the machine coordinate system visibility on, the machine coordinate system visibility, machine tool coordinate system is rotated or transformed from the world coordinate system. So just to make it easier, I'm going to toggle the display of the world coordinate system off so it's easier to visualize it. So your world coordinate system is still, the Z is normal to this face the way you had it designed, but for machine tool we oriented the coordinate system in here. So you can see now the machine tool coordinate system, the Z is normal to the top face. So this is a very easy way and a very intuitive way to orient your coordinate system for establishing your machine tool coordinate system when you're working in SolidWorks, where can't really perform CAD transformations, too many CAD transformations to establish, and it's a very easy and efficient way to establish this. Now once you've established this, you can then go ahead and establish your machine tool. So all your machine tool definition, your stock definition, all of these are based off of the orientation of the machine tool that you establish. Now if I go ahead and define a stock geometry in here, you will notice that the length is based off the orientation of the machine tools, which is basically it's 10.5 inches, which is the distance along the x-axis of your machine tool coordinate system, and not based off the just x-axis or the y or the z-axis of the world coordinate system. So it's based off the orientation of the machine tool. So your z-axis or the height of the part is 1 inch, and that is based off the orientation that you established for the machine tool coordinates, and likewise for the y-axis as well. So once you established your stock, you would then go ahead and establish your work 0 in here to establish your machining coordinate system origin, or this is also known as your program or the work coordinate system origin. So to do that, you would go into work 0 and you can specify where you would like to establish your machining coordinate system origin. This is can be done using by pick, and you can pick a point, you can pick a vertex, or you can choose set to stock. You can pick 0 face as a highest Z, which is the top face, and 0 position could be your southwest corner, and then you can pick generate. So you'll now notice that your machining coordinate system origin is established to the top of the stock and the southwest corner. Your machine tool coordinate system is oriented, and the work 0 just performs a translation or a transformation from the machine tool coordinate system to the machining coordinate system origin, or also known as the program or the work coordinate system origin. So this is how you could establish your machining coordinate system origin for when you're working within SOLIDWORKS. Now, one of the things we would also like to cover is how we can create additional setups to be able to program parts from additional orientations. So in this particular case, you see that the part in here has to be machined from at least 2 sides, as this particular hole in here cannot be machined looking through the part looking down from the top in here. So we would have to establish an additional orientation to machine this part. So this feature called setup or coordinate system setup or additional coordinate system setup is available in our Pro and Premium configurations, where you can create additional setups. You can go into setup and select setup, and this allows you to create an additional setup where you can transform the coordinate system from the initial machine tool coordinate system origin that you define into a new orientation. So I could use select surface, and I can pick a face, and you will now notice that the z-axis would be oriented based on the normal direction of that surface or the face that you selected, and you can also rotate it if you need to. You can use these controls to rotate the coordinate system and then select OK to accept it. So you now have a new setup. So the initial setup is in the orientation of the machine tool that you define, and we have a new setup which now orients the z-axis normal to this particular face. Now once you've established a new setup, you could go ahead and add an additional work 0 if you need the work 0 to be placed at a different location. So for example, if I need to place the work 0 at the center of this hole, I can use this feature called pick, and I can go pick a point right in here. I can pick the point right there. You can see that the 0 is now being established right on that particular face in the center of the hole. So you can have a work 0 defined under each setup. You can have 1 or more work 0s established. So when you program your tool paths in post-process, you can output each setup to a separate output file, your G-code output file, or you could pause the entire machining job and use pause statements or pause commands to pause between the setups. That'll give you ample time to go back and refix the part, reorient on the machine, and then continue running the program. So this is how you can create additional setups in
Uday, one of the attendees had a question about creation of stock in SOLIDWORKS. So if you can show how stock was created and in SOLIDWORKS, that is. Thank you.
Sure, thank you. So the stock geometry can be defined by going to the stock menu under the program tab. There's a group called stock. You could go down to stock and choose box stock, and this automatically creates the stock based on the initial orientation of the machine tool that you've defined, and you can specify your X, Y, Z extents of the stock, and by default it'll compute the a part bounding box, which means a stock that will fit the part based on the bounding extents of the part, and you can establish a box stock. There's also additional ways how you can define stock. You could use part box stocks, cylinder stocks. You could also define stock by selection, where you could actually select features from your feature tree in here. So if you have a stock where you need to suppress some of these features in here, I could go ahead and roll back some of these features in the feature tree right in here. I could choose my stock to be of a certain shape right in here. I can select this. I could also perform a stock from a selection, so you now have a stock that's basically predefined a pre-cut shape, and now you can go back and unsuppress these features that we just suppressed in here, and we can program these toolpaths from it. So you can define stock using different techniques, and we just talked about box stock. We also looked at stock from selection in here. Now the stock from selection is offered in the Pro and Premium configurations of our product.
One important thing to point out in the stocks creation menus, especially if you go to a box stock, and the coordinates that you type in are in relation to your machine coordinate system, not the design coordinate system. That's an important distinction to realize.